For today, we will be looking at work, energy and power. When we say work, it can be used in so many contexts. An example is when dad says he's off to work or when mom says she needs you to get the work done quickly. Now in physics, mechanics, work tends to have a slightly different definition. Work in this context is simply when a force F moves a body through a distance s. The unit of work is joules. Now take for instance, you found your missing pen under the couch and you needed to get it out, so you have to push the couch to get it. So now, the push you applied is a form of force and it moved the couch through a distance. So the work done now by you is whatever amount of force you applied to it multiplied by the distance it covered. Note that the unit of force is Newton and that of distance is meters. And the SI unit of work done is joules. So work done W equals F times S, where F is the force applied and S is the distance covered by the effect of the force. Now this is my friend Scott. If I push him, HS staggers back and covers a distance.
Yes, let's assume he's pushed with a force of 10 Newton and he covers a distance of 3 meters. The work done there becomes W equals F times S, which is 10 times 3. So we have 30 joules.
So now, everyone has weight. Now if I move a distance of 3 meters, work has been done because I moved my weight through a distance.
Here we go again, a very quick one. You heard him say that moving his weight through a distance is also work done, instead of moving a force through a distance. Yes. It's absolutely correct. We basically define force as a pull or push applied to a body. In this case, our weight is as a result of the gravitational force acting on us. And it acts downwards. It's given as weight W equals our mass multiplied by g. That is acceleration due to gravity, which has a value of 9.8 meters per second square and an approximate value of 10 meters per second square. So W is equals m times g. Its unit is also in Newton, just as that of the force. So have it in mind that weight is also a form of force.
So with that, work done can also be given as W equals m times g times s, that is, mass times gravity times distance covered. So we can have it as milligrams, and if I cover a distance, let's say while walking up the stairs, the distance covered in this context becomes the height.
Okay, here, height is also a form of distance. So just you don't get it all mixed up, distance is the length of space between 2 points. So if the length of space between 2 points here be vertical, then it can be referred to as height. But note that it is still a form of distance.
So work done here becomes m times g times h. That is mass times gravity times height. mgh. So now let's take a quick example on this.
Calculate the work done by a boy of mass 70 kilograms in climbing a tree 6 meter high. Take g equals 10 meters slash s circumflex 2 quickly. Mass is 70 kilograms. Height is 6 meters and the gravitational force is given as 10 meters per second square. So, work done equals mgh.
So W equals 70 times 10 times 6.
That is about 4,200 joules. Wow, that's a lot of work done by the boy. He must be really strong.
And so that's it on work done. You can try out more examples and as well check the next video on energy. Thank you so much for your time watching. Please do us a favor of subscribing to this channel to get notified on new videos. And I hope this lesson was well understood. You can leave your comments in the comment box below. And of course questions. Thanks.